Good day, everyone. Today I'm going to discuss annuity. And for this lesson, I divided the discussion into two separate lecture videos. What is annuity? Annuity is a sequence of equal payments made at equal intervals of time, usually monthly, quarterly, semi-annually, and annually. Annuities are a series of cash payments that are paid or received over time at regular intervals. Now, annuities can have equal or different amount payments, but they must occur regularly. That's the idea. Perhaps the earliest annuity most people have experienced is the school allowance. Then there are the apartment rentals, the cell phone staggered payments, the lease payments on car, etc. If there are recurring payments that may be considered, and we call it as annuity. Since the regular payments for an annuity over a time, problems brought by inflation or rising prices over the time should be also considered because these affect the value of annuities. Inflation changes the buying power of money. Hence, the annuity payments from the year to year, for example, may not have the same buying power because of inflation. Now, to correct inflation effects, a discount rate must be incorporated into the annuity formula. In coming up with the formula for the annuity, aside from the inflation, two factors are taken into consideration. First is the timing of payment, whether it is paid at the beginning or at the end of the period. And secondly, future value and present value perspectives. There are two types of annuities. Basically, they are simple and general annuity. When we say simple, it's one in which the payment periods coincide with the interest conversion periods, while general annuity is one in which the payment periods do not coincide with the interest conversion periods. There are classification of annuities, and they're classified according to time and according to mode of payment. This one should fall here. So we only have three according to time and another three according to mode of payment. First is annuity certain. An annuity certain is an annuity in which payments extend over a fixed term. The term in this annuity begins and ends on definite dates. When we say contingent annuity, this is an annuity in which payments extend over a period and extent of term is dependent upon an uncertain occurrence or condition. When we say perpetuity annuity, so this is an annuity in which payments continue forever. Now we have, according to mode of payment, ordinary, annuity due, and deferred annuity. So when we say annuity, ordinary annuity, this is an annuity whose payments are made at the end of each payment interval. And then annuity due, this is an annuity whose payment are made at the beginning of each payment interval. When we say deferred annuity, so this is an annuity whose first payment is to start at some future date. For example, you have borrowed an appliance, and some other lending institutions offered lending, for example, money, and then they offer the payment in the future, like after a year they'll start paying, so that immediately after acquiring the item. So that's deferred annuity. Um, for this lesson, we will focus on simple annuity certain, where payment intervals are the same as interest conversion intervals and the term is fixed. The payment interval is the period between the successive payment dates. The time from the beginning of the first payment interval to the end of the last one is called as the term of an annuity. Take note that the total number of interest conversion periods is denoted by N. Hence, N is also considered as notation for the total number of payments. The annual rent of an annuity refers to the sum of payments in any 1 year. Now, an ordinary annuity is an annuity in which payments are made at the end of the payment periods, as you can see here in the illustration. So first payment is made at the end of the first payment period, and the last payment coincides with the end of the first payment period. The amount of an annuity is the sum of the compound amounts on hand at the end of the term or at the end of the first term. Each payment accumulates until then from the date when it is due. So the amount of an annuity is the value of the annuity at the end of its term. So we will, in this figure, this is an ordinary simple annuity of 1,000 pesos, which is payable for 4 years with interest rate of 3%. Now, we're going to make use of the capital R for each payment in an annuity, or this one is the regular payment. And then the time from the beginning of the first payment period to the end of the last payment period, we'll consider this as the term of the annuity. Now, payment interval is the time between successive payments and an annuity. Now, we also have future value, and we denote future value by FV. Future value is the value of a group of payments at a specified date in the future. That's why it's called as the future value. Now, the future value of an annuity measures how much you would have in the future given a specified rate of return or discount rate. Now, in the example, 1,000 pesos is the periodic payment. The payment interval is 1 year, and the term of the annuity is 4 years. Okay? So, T equals 4 years here. So, to generate the formula for the future value, S. So, our notation for the future value is denoted by S. We will let R be the amount of each payment in an annuity. Now, R will be the regular payment, while the small r here will be the interest, the annual interest rate. M be the number of times the amount of each payment or the interest is compounded per year. So we consider this as the compounding period. For example, if it compounds monthly, then M equals 12. If it's semi-annually, then M equals 2 because there are 2 6 months in a year. Okay? And we denote T as the time in years. Okay? So we need to divide R by M which is denoted by, so we will divide R by M, and let's denote this by R equals J over M. Since the new interest rate is the interest rate conversion period. Now, and this given will come up with the future value equals R and then plus R times quantity 1 plus I plus again R times quantity 1 plus I to the second plus R plus quantity 1 plus I to the third, and so on until R times quantity 1 plus I to the n. Now, again, we're n here. Take note, should be equal to the product of the compounding period and, of course, the time. Now, looking at the pattern here and working on the common factor, moving out the common factor, we'll come up with S equals quantity R times 1 plus 1 plus I to the second plus 1 plus I to the third plus up to 1 plus I to the nth. And this formula seems familiar to you since the bracket contains a geometric series of n terms with common ratio of 1 plus I. Now, applying the formula for the geometric series will come up with the future value equals R quantity 1 plus I, which is the common ratio, raised to the n minus 1. Okay, should I place it here? S again equals R times quantity 1 plus I. So 1 plus I, guys, here is the common ratio. And then we raise this to the n power minus 1, right? All over I plus 1, or rather 1 plus I. Well, it's the same, minus 1. Now, simplifying this equation or formula, we will come up with S equals R times quantity 1 plus I to the n minus 1 all over I. And this one will be our formula in solving for the present value of an annuity. So let's work on example exercises involving future value of an annuity and solving for the regular payment. Okay, so number 1, find the future value of an ordinary annuity for 2,000 pesos a month for 10 years if the interest rate is 6% compounded monthly. So let's consider R. So R here equals 2,000 pesos. Okay. And your R, or the annual interest rate, equals 6%, 0.06. We have to divide that annual interest rate by the compounding period, and that's 0.06 divided by 12 because this is compounded monthly. And then we have I equals 0.005, T equals 10 years, your N equals the product of M and T. So M equals 12 and T equals 10. So the product of 12 and 10 equals 120. Substituting the given in the formula to solve for the future value and using your calculator. So S equals 2000 times quantity 1 plus 0.005 to the 120th power less 1 all over 0.005. And rounding off the answer to the nearest hundreds or centavos, we have future value equals 327,758 and 69 centavos. So this will be the accumulated value after 10 years. Okay, so we have number 2. So this is about retirement. Now, a 20-year-old woman wants to retire as a millionaire by the time she turns 70. How much will she have to save at the end of every 3 months if she can earn 3% compounded quarterly, tax-free, to have a million by the time she is 70? So with that long-term plan of, getting 1 million is also the application of future value of an annuity. So by inspection, R is being asked in the problem since we are asked on how much the woman will earn, will save quarterly just for her to receive 1 million pesos as she reached the age of 70. So R here is missing. And by inspection, S equals 1 million pesos, 1 million. And then the annual interest rate equals 0.03. Then we have to divide that 0.03 by 4 since there are 4 quarters in a year. And I equals 0.0075. 0.0075. Then N equals the product of MT. M is 12 while T equals 50 and N equals 200. So substituting the given in the formula, we have 1 million. Our R is missing, so let's just write R as is and then continue with the substitution of the given in the formula. So we have 1 plus 0.0075 to the 200 power minus 1 all over 0.0075. And everything will be done by your calculator. So you just have to verify whether you have entered the correct figure in your calculator. And then do not forget to round off your answer to the nearest hundreds. So we have 2,169 pesos. You just have to save 2,169 pesos, 0.72 per quarter. Imagine for 50 years for you to realize 1 million pesos when you reach the age of 70. My God. Okay. Next. So suppose you are considering to avail a data plan for your smartphone. How much is your monthly expenditure for 2 years compounded monthly at 4% annual interest rate if the future value of the plan is 24,909? Now, we have to note that again, R is as in the problem, the periodic payment. It's the monthly periodic payment. And considering the given here, our R annual interest rate is 0.04, and we have to divide that by 12 because this is compounded monthly. So we have 0.04 divided by 12. We have 0.0033. Okay. And then n equals the product of 12 and 2, which equals 24. And then the future value equals 24,909. Okay. And then again, substituting the given in the formula. So we have 24,909 equals R is missing. So let's represent that by R times quantity 1 plus 0.0033 to the 24th power less 1 all over 0.0033. Okay. And then use your calculator. So after substituting the given, take note that R is as in the problem. So what we're going to do is to divide both sides by the second factor from the right side of the equation to isolate this R, and of course comes up with the value of R. So we'll divide both sides by this factor. So we have 1 plus 0.0033 to the 24th minus 1 all over 0.0033. Okay. So the purpose is to isolate R, and we'll be able to solve for R, of course. So, of course, this will be canceled, and solving for R requires us to divide the numerator by the denominator. So after doing so, we'll come up with 999 and 4 centavos. So this will be your monthly expenditure to achieve this future value plan amounting to 24,909. Now we proceed with the present value. When we say present value, so this is the amount of money needed to receive a series of payments for a given number of years in the future, and which is, we call this again as the present value. For example, we're going to use the same annuity cash flow schedule as we did in the first figure. Now, to obtain the total discounted value, we need to take the present value of each future payment, and as we did in the figure here, so we'll come up with working backwards in comparison to the future value. When we say present value, literally we are working on the current or the present value itself. Like if you remember with the previous example of how much are you going to borrow money, if you just, for example, if you can only afford, let's say, to pay 1,000 pesos a month, and of course, how much money are you going to borrow? And that's working on the present value. So with the present value, we'll be working with another lecture video